Good evening, ladies and gentlemen. So today we are going to talk about von Neumann model. So what is von Neumann model? Okay, let's see, guys. Okay, who is this von Neumann model? So we're going to have a picture on him at the screen. All right. Okay, let's pause this video. Okay, John von Neumann, or his real name is Janos Neumann, born in December 28, 1903 in Budapest, Hungary. He's and he died in February 8, 1957 in Washington D.C. He's a Hungarian-born American, and he's a mathematician. Well, he has a gift of applied mathematics. Took his work in directions that influence quantum theory. So, in other words, he has impressive works with his friends called Claude Shannon and Alan Turing in doing some conceptual invention of storage para-digital computer. Okay, let's get forward with the video. Okay guys, all computers more or less based on the same basic design. They are using von Neumann architecture. The model for designing and building computers is based on the following three characteristics, which is the computer consists of four main subsystems. That is memory, ALU, control unit, input-output system, and the second one is the program is stored in memory during execution, and the program instructions are executed sequentially. This is the von Neumann model on how it looks like. So there are 5 components in von Neumann model, which is control, processing unit, memory, input, and output from the CPU to the user.
Control unit reads an instruction from memory. The instruction address is in the PC. The second one interprets the instruction, generating signals that tells the other components what to do. An instruction may take many machine cycles to complete. Instruction register IR contains the current instruction. Program counter PC contains the address of the next instruction to be executed.
2. Processing unit. Processing unit is hardware that implements arithmetic and logical operations. ALU stands for Arithmetic and Logic Unit, and capable of performing add, subtract, or and not operations. The size of input quantities of ALU is often referred as word length of the computer. Many processors today have word length of 32 and 64 bits.
Okay, the third one is memory. There are 2 types of memory in the von Neumann models. The first one is fetch, which is address, which returns value without changing the address, and the second one is store, which is address and value. This function writes new value into the cell at the given address. This type of memory is random access, meaning that the CPU can access any value of the array at any time, such as sequential access like annotate. Such memories are called RAM, random access memory, which is we can see in our daily basis in normal computer. Also, some memory is non-volatile or read-only, like ROM or read-only memory. The memory operations can be seen on the figure above. There's two types of memory, MAR and MDR. And using command lines such fetch and store, MAR is the only way for the CPU to communicate with the address bus, while MDR data can go in both directions to and from the memory.
And fourth and fifth is the input and output. Devices for getting data into and out of computer memory. Each device has its own interface, usually a set of registers like the memories MAR and MDR. These are what the devices are for the input and output. Input and output controller provides the necessary interface to input and output device, takes care of low-level device-dependent details, and provides necessary electrical signal interface.
In conclusion, as we know that all computers nowadays are using von Neumann models in its system. So without von Neumann model, surely there won't be any computers nowadays. Thank you.